So this is our first example, and this is just a general titration example. So the first example is 18.50 ml of hydrochloric acid is neutralized by 25 ml of potassium hydroxide solution, which has a molar mass of 56 grams per mole, containing 7 grams per liter of potassium hydroxide. So what is the molar concentration of the acid? So the first thing we need to do when we are given such a problem is we need to draw our balanced equation. So we have to write down our balanced equation, which is then we have hydrochloric acid, which is HCl, reacting with potassium hydroxide to give us, okay, HCl plus potassium hydroxide will give us sodium chloride plus water. So the next thing we need to consider is if our equation is balanced. So starting off with the potassium, we have one potassium here, we have one potassium on this side. So potassium is balanced. Then we come to our chlorine. We have one chlorine on this side, we have one chlorine on this side. So chlorine is also balanced. Oxygen, we have one oxygen this side, we have one oxygen this side. So our oxygens are also balanced. And hydrogen, we have two hydrogen here and we have two hydrogen here, so our hydrogens are also balanced, hence our entire equation is balanced. So the next thing we have to do is allocate now the volumes to the specific compounds. So we know that 18.50 ml is of hydrochloric acid. So what we can do is we just write it down here. So we have 18.50 ml of HCl was needed to react with 25 ml of potassium hydroxide. So 25 ml of potassium hydroxide. So, and we know that, okay, containing 7 grams of potassium hydroxide solution. So we have the concentration of our potassium hydroxide solution, which is 7 grams per liter. So we can just put it here, 7 grams per liter. And the thing is now, what is the molar concentration of the acid? We do not have the molar concentration of the acid, and that is exactly what we are looking for here. So we can just put a question mark. So the next thing we will then do is we will then do the C1, C1 V1 equals to C2 V2, which is C1 V1 equals to C2 V2. So now we can then allocate, since this is C1 V1 equals to C2 V2, what we can do is we can say this can be for the acid, which is the HCl, and this can be for the base, which is the potassium hydroxide, right? But now here is a challenge, because if you can see this concentration, it is in grams per liter, right? And our volume here are in ml. So it's going to affect our result at the end of the, once we get our result. So we have to convert these milliliters to liters. So 18.50 ml to liters will then give us 0. We'll then get 0.0185 liters. Question mark here. And the 25 milliliter to liter, we then get 0.025 liters in with a concentration of 7 grams per liter. Okay, so once we do that, we have all our volumes in the same quantity as well as our concentration, so we can then proceed with our C1 V1. So C1, which is our initial concentration of HCl, we know that we do not have it, which is here, so we it is what we are looking for. So we can just put it as C1, and you know that our volume, our first volume is 0.0185 liters. So it will then be 0.0185 liters, which is then which we multiply with the volume and concentration of our potassium hydroxide, which will be 0.025 liters multiplied by 7 grams per mole. So we just make it the subject of the formula. C1 will then be that 0.025 liters multiplied by 7 grams will give us to give us 0.175. So that's 0.175 over 0.0185. So our C1 will then be 9.46 to then be 9.46 grams per liter. Therefore, um, therefore our concentration, our HCl concentration will then be 9.46 grams per liter. But we know that this is not, the question is asking what is the molar concentration of the acid. So the units for molar concentration, it is moles per liter, not grams per liter. So what we can do is then convert this grams per liter to moles per liter. And how we do that, we divide this answer over the molar mass of HCl. So the molar mass of HCl is 36.46. So I then convert it 36.46 grams per mole. Then it will then give us a concentration of 0.26 grams per mole. Sorry. So that is our final concentration of hydrochloric acid. This question is, this answer is also correct, but we should always be cautious because the question is asking molar concentration. So we should always make sure that we put in the desired units. But yes, that is our final answer.